Welcome back. Today we're going to take a quick review over some things we've talked about lately pertaining to frequency distributions. One of the first things we'll look at is finding the mean of a set of data, or estimating the mean of a set of data that we have arranged in a frequency distribution. And in addition to that, we'll take a look at finding the standard deviation of that as well, which can get quite hectic at times. It's a little complicated, but sticking to our process, we can easily follow it out and get an answer. Let's go ahead and take a look at this example. The following frequency distribution displays the data on the ages of each president of the United States at the time of their inauguration. This is actually some data that we've put together ourselves in a previous assignment, and we've worked with this data a little bit previously. So now we're going to find the mean of this. And in order to do that, you actually have to get a little bit of extra information. So we're going to add in a couple of columns here. And the first column is for the midpoint of each class. And the second column that we're going to add on is for frequency times midpoint. Now there's a reason why we're doing this. As we look at this graph or this table, there's more data here than just the 6 values that we see in this list. Keep in mind that we have a class of presidents that comes between 42 and 46 in age, and there are actually 4 presidents that fall into that category. So we don't know what the exact age is from this data that we've been given here. However, we are just going to have to come up with a value to attribute to that, since we don't have anything else in this particular problem anyway. So what we're going to have to do is find the midpoint of that class, and we will count all 4 numbers in that class, all 4 occurrences, as that value. Now the midpoint can be found by adding 42 plus 46 and dividing by 2. Well, 42 plus 46 is 88, and 88 divided by 2 would give us 44 as the midpoint. Going to the next class, 47 to 51, the midpoint of that, 47 plus 51 is 98. We divide that by 2 and get 49. The midpoint of the next class, 52 to 56, is 54. And I'll kind of rush through these last few. 57 to 61 would be 59. Midpoint of 62 to 66 would be 64. And the midpoint of 67 to 71 would be 69. So what we're doing, and again, what we're going to say is every item in this class, which had 11 presidents in it, that were aged somewhere from 47 to 51, we're going to count all 11 of those as being aged 49. And the only reason why we're doing that is we don't have enough information to do anything else. Now we have seen this other data, so we'll just ignore the fact that we know this data. But in most cases where all we have is a frequency distribution, we have to assign some value to that class. So what we assign is the midpoint. Now, in order to average this up, remember that the average, or the mean, is the sum of all the x's divided by n. And for what we've learned at this point, that's the way we would figure that out. So we need to add up all the values and divide by the number of values we have. Now in order to do this, we can't just add up the midpoints and be done with it. That doesn't work. The reason being is that I don't just have one number 44 there, I have 4 of them. So we have to multiply the frequency times the midpoint in every case. So we'll multiply 4 times 44, and that gives us 176. We'll multiply 11 times 49, and I believe that gives us 539. We'll multiply 14 times 54. That gives us 756. 9 times 59, that's going to work out to be 531. And 4 times 64, of course, is 256. And then 2 times 69 is 138. So what we've done is multiply the frequency times the midpoint to basically figure out what all of the numbers in each one of these classes are going to add up to be. And for instance, the 4 numbers in this class from 62 to 66, we attributed 64 to be each one of them, and that would have a total of 256 for that class. Now what we need to do is get a total for all of them all together. And that sum would come up to be, let's see, 2,396, I believe, as we add those up. Yeah, let me double check that's correct. Okay, so we get 2,396. Now, we're going to have to divide that by n. Well, what is n? N is going to come not from the number of classes that we have, so it would not be 6. We have to use the frequencies to get in. Okay, so we'll add all of the frequencies up. Remember, we had 2 presidents here, we had 4 here, 9 here, 14 here, 11 here, and 4 here. So as we combine all of those, that gives us a grand total of 44 presidents. So we will use this 44 as n, and we will divide 2396 by 44 and find the mean, and we'll learn a little bit more about population means later, but for right now we'll call the mean x bar, and that mean will be 54.45. That is our mean for the list of presidents' ages. And quite simply, that's the process we're following. Anytime we find the mean of a frequency distribution, we're going to multiply the midpoint of each class times the frequency. We'll get a total, get a product for each one of those, and total those up to divide by the total number of frequencies. And that will give us our mean. Let's say we continued to work with this data and we were asked to find the standard deviation of the ages, and that becomes a much more involved process. Remember, standard deviation in general, I'm running out of space, standard deviation, which we'll call S, is the square root of the sum of each item being subtracted from the mean and squared. We add all those up and we divide by n minus 1. So we've got a lot of work here to get all this information for a frequency distribution, or from a frequency distribution. So as we look at this, we remember again that we have several items in each class. Now I've already put up the data that we had from the previous one, remembering of course that x bar was equal to 54.45, and we figured out also that n was equal to 44, meaning we had 44 presidents that had a mean age of 54.45. So we're going to apply that, and the first thing we're going to do as we jump into this problem is we are going to find what each item, which we'll call the midpoints, remember that's what we're counting each item as, minus the mean is. So we're going to take each item and subtract it from the mean, or subtract the mean from it. Now as we do that, that would be 44 minus 54.45, and that is going to give us negative 10.45. We do it again, 49 minus 54.45, that's going to give you negative 5.45. 54 minus 54 minus 54.45. It's been a long day. That gives us negative 0.45. 59 minus 54.45 is 4.55. 64, subtracted that would be 9.55. And 69 minus 54.45 would be 14.55. Now again, typically when we work out the standard deviation, when we subtract x minus the mean, those values typically all cancel each other out. In this case, it's not going to happen, and that is because I don't just have one number coming out to be negative 10.45. I have 4 of them, and that getting counted 4 times, and this getting counted 11 times. This one over here counts 11 times. This one, negative 0.45, counts 14 times. So they're not all balanced. So of course they're not going to cancel each other out quite the same as we would get in a normal problem here when we were just figuring out standard deviation of a group. So keep that in mind. We have frequencies to account for, so that's not going to work quite the same way, but we still have to follow the rule. The rule says that we have to take each of these values, let me clear that out. We have to take each of these values and square them. So we're going to take x minus x bar squared and work with that. Real quickly, I'll go ahead and fill those in, but basically what I'm going to do is I'm going to take negative 10.45 and square it, raise it to the second power. That would be 109.20. I'm going to go ahead and complete those real quick and come right back. Okay, you can see I'm back here and I've completed that list of x minus x bar squares. And again, I'll repeat the fact that we do have multiple occurrences of each one of these values in this list. They're not just there one time. When we remember that we have frequencies in each class, each of those frequencies is telling us how many times each one of these numbers occurs. So we have to take that into account, and we'll do that in the last column here. We'll multiply frequency, and I'll see if I can fit it all in here. Frequency, I'm writing real small, x minus x bar squared. We're multiplying those two together. So as I do that, I'm going to get some really big numbers in some cases. I'll say 109.20 times the frequency of 4. That gives me 436.81. That's due to rounding. The 20 was actually not 20. I just cut it off there because I couldn't fit it all in. But when we get that, we get 436.81. 29.70 times 11. And again, this was rounded off a little bit. So when I do that, what the actual number was 326.73. Now you want to, I'm mentioning the rounding here. You need to be careful with rounding in the midst of a problem, in the middle of a problem. You don't like to round a whole lot. You'll notice if you work this out, you might be a little bit off from what I'm getting. Really, those differences are not too much to stress out over. You might have gotten 436.80 for the first number. That's fine. Again, it's a very small difference when you consider the magnitude of the numbers and how much we're doing here. Again, just be conscious of it. Try not to over round too much, and do your best to try and keep at least a few decimal places there as you work these out. The next number is 0.20, and we're going to multiply that by 14. Again, that was rounded off to 0.20, but this gives us 2.84. The next one, 20.70 times 9 is going to give us 186.32 as a rounded value. The rounded value of 91.20 times 4 is going to give us, again, 364.81. Then we see 211.70 times 2. That's going to give us, when it's the rounded off value here, multiplied by 2 is going to be 423.41 when we get a rounded value. So you can see, again, I'll repeat, don't get stressed out over the rounding of values in that last decimal place. You might be a hair off based on how you rounded some things. Just be cognizant of the fact that we don't want to over round. We want to carry a few decimal places as we're working on these numbers or with these numbers in the middle of the problem. Now when you get to your final answer, you might want to round off your final answer, and that's fine. Continuing along, we're going to add all these values up. And I can tell you I've already got it worked out that the sum of these is 1740.91. Now, the question is, what do we do with that? Well, we go back to our formula, and we are now going to look at what we've got in the formula. See what we can do to carry that over here. Well, S is going to be equal to the square root of the sum of the x minus x bar squares. Well, the sum of all of them was what we got when we took each one and multiplied by the frequency to account for all of the occurrences that we had. So that sum came out to be 1740.91, and that was why we went through that whole ordeal of making this large table, was to get that value. So we're going to take that 1740.91, we're going to divide it by n minus 1, and again we get n from the sum of the frequencies. All of these frequencies in this list added up here are going to give us an n of 44. So we'll apply that in, and we'll say 44 minus 1 would give us 43. Okay? Now, real quickly, you will see that when we just take this part, you will find the variance, and that's just s squared. The variance is x minus x bar, sum of all those divided by n minus 1. That's exactly what we're working out underneath this radical. Well, in this case, that comes up to be 40, somewhere around, I guess this is rounded off, 40.4863. And again, that's a rounded off answer. To find s would be the square root of that. And that's just a continuation of what this value is. Square root of 40.4863 is going to end up being somewhere around 6.36, we'll say. That is our final answer for standard deviation. So we can see, through looking at these values, we've gathered two pieces of information from this. We first off found that a mean was 54.45. You may want to round that off to 54.5 based on our rules of rounding that we've talked about in class. The standard deviation was 6.36 or somewhere thereabout. And again, you might want to round that off to 1 decimal place. That's the way we've been sticking with this rule. So that would be 6.4. So we'll get more into later about exactly what this means, but what we're saying is that the average age of a president at inauguration is somewhere around 54.5 years old, and that the values within all those presidents varies from the mean. In other words, they'll be about 6.4 years off of that mean on a typical observation. So as we go from observation to observation, some of them might be closer than 6.4 units from the mean, some of them might be further away, but on average, your typical value is going to be about 6.4 years off of the mean of 54.5 in this case. Okay? Well, have a good day. I hope you got a little bit more understanding of this topic, and good luck. We're going to have a quiz coming up, and I know you guys are going to do a great job on it.